Okay, I get to be the moderator.
Oh, God.
Outstanding. Welcome to the, what's the official title? It's I think, thermal envelope technology. As we alluded to, my name is Brendan Kelly. I'm the architect. I'm going to introduce this amazing panel here in a moment. One of the remarkable parts about the BONE technology isn't just the steel structure and how it responds to earthquakes and how it arrives in flatbed trucks and how you put it together with you know, screws instead of nails, but how it accommodates up-to-date thermal envelope technology. Also in the audience today, before I introduce my panel, is Amy Hutton with Golden State Lumber.
Hi.
And she has a new showroom right down the street on Airport Boulevard. Golden State distributes both Andersen and other window suppliers, none of which will be named right now because I want to introduce Blaine Beckman, who's our Andersen window rep. He's got a terrific table out there. Windows are a big part of thermal envelope pieces. If you were here for the 9:30 session, the walls are really not the issues. Making sure that they're protected, it's all important. It's really the windows which are the weak point in any thermal envelope. And I'm sure Blake will have some comments. Alex Tureck has a lot of experience as a contractor, but on this project in particular, he's kind of like the guardian angel. And Mike Dethlefsen, who's the contractor, really was given Alex by BONE for a number of weeks, so that as the structure arrived, Alex is a BONE employee because you can tell by his cool swag. But Alex is an expert at putting this system together. And the great story that Ray Alden tells is that Alex can see somebody trying to drill something at an angle from about 100 yards. And Alex will go, "Stop!" And if anything is not happening at right angles, Alex will see it like inherently. I mean, even if it's behind him, he'll know it's off. So Alex is a big part of why it looks so solidly built today. And Charles is the Chief Product Officer for BONE, a fellow Stanford grad, which I had to sort of plug there because there's a lot of Stanford grads involved in this project. And but Charles and his dad, of course, Mark, are instrumental in not just this project, but getting BONE technology and the thermal envelope tested through different through the different phases. And I know you're going to hear all three of these different perspectives about how we sort of talk about thermal envelopes. So before we start, I just want to have 2 or 3 questions that you guys are kind of at the top of your mind before, so that we can maybe address them during the conversations. Are there any questions about thermal envelopes or windows before we get underway? It's okay that you don't have any. Okay, good. Off to the races. We have, so Blaine, the first question really is to you. And Charles and Alex have other experience with all kinds of other windows. What is different about a window today, even though you can see through it, than say maybe 10 years ago?
Well, there's a lot that's changed, and the technology is moving at the speed of light. Not only the materials that we build them out of, the glass technology is another one. A good example is we're using some composites now, a product called FiberX, which is one that's recycled wood fiber in one of our product lines, and several different components of other windows. We're using some fiberglass in some of our products. So it really depends on the need of the project. If it's super high performance, we can create that by using a certain group of materials to get that. If it's a special color need, another group of products and materials will help us get that. So we have a lot of different materials that we're using that's not the typical old window.
Alex, you've installed many kinds of windows on many kinds of BONE products. What would you sort of say are the challenges and opportunities in specific window installation and choices within the BareBONE structure system?
Well, so bone structure, the positioning of the windows is important for us. So in a typical house, you've got options whether you want to put your insulation embedded in your framing versus outside, attached more towards the exterior of your envelope. Something that we do in BareBONE is position the windows in your insulation cavity or in your insulation profile for a better performance. That said, you can see here we went with an Audi window. So there is a lot of flexibility. Yeah, cornerless, you know, being able to cantilever joists, being able to have clear framed window corners is another option. There's a lot of opportunities within the depth of our wall to do what is known as like a passive house window installation, where you're actually bringing your insulation all the way around into your frame of your window to create not only incredible insulation R value, but also air tightness. So one thing we're working on internally is developing window details using the latest in seam tapes, sealants, to be able to get as airtight and high R values as possible with flexibility with every single window that's on the market. We work with European window manufacturers, local window manufacturers. So yeah, I guess just to summarize, what we're providing is a pretty open canvas kind of to work with.
And if I can just
Yes, of course.
expand on that, is the challenge is, you know, a window is like a transparent wall, pretty much, right? So if you're innovating and you're pushing the envelope in terms of how you build your wall section and you reach high insulation values and good air tightness, well then the real challenge becomes at some point you're better off focusing on the windows, because that is the weakest link in the shell. So we wanted to be able to accommodate different products because we build on the East Coast, on the West Coast, in Canada and in California. We designed an opening that could accommodate for the different regional or whatever options the architect would want to have. In any case, what we're going to do is push for a window that's going to be, sure, architecturally pleasing and sexy with a thin profile, but at the same time that will be well designed, that will be thermally broken, that will have the right fit, not just architecturally, but in terms of complementing the shell, because otherwise you're kind of leaving some, you're half-assing, if I can say.
The technical term?
Very technical term.
You're right about the thermal break is the big, one of the things that we're incorporating into a lot of our products, and how do we slow down that transfer of heat and cold, to the maximum, right? That's the challenge that we have. And with people wanting bigger, taller, wider windows these days, they want all glass. That's a big challenge for us.
In this climate, in any climate, the windows are the weak points of a thermal envelope system, but you also, in this climate specifically, you want a lot of outdoor, like on a day like this, when many windows would be open, and there's really not a need to passively heat or cool through a big part of the day or the week. But that same big door that opens, I mean, I'll tell you, as an architect who's done dozens and dozens of projects with all kinds of complicated window schedules, I'm still learning things from very specific technical window suppliers. I remember thinking like, okay, I've got everything done. I've got my window details figured out. I send it off to Amy, who received my plans and my beautiful drawings. And she called me back. She said, well, we need about an hour on the phone to go through all the problems. And I said, what? That's perfect. And she, and so the nice part, and what I'm warning you about, is that when you're talking to your architect and they don't have somebody like BareBONE or a really good window expert, especially about a new house, you definitely are going to want to question that person, because it's pretty easy to put insulation up, the wall pieces. Of course, if you have a bone building, it all comes kind of as a uniform sort of circular package. A lot of the bone pieces are, a lot of the bone windows in other homes that you guys have done are aluminum. Steel windows are not thermally broken through the insulation, so there's a real struggle with some of these high-end steel windows. But one of the design pieces, and I want Charles to talk about this, is how the wood bucks. And a window buck is the wood frame that fits into the steel system for the window frame system, and all of those wood surrounds come with the bone system. So could you just talk about it?
Yeah, that's a question that we get.
Aluminum and wood windows.
That's a question that we get all the time, just starting with the how we design our system to be able to integrate multiple different window types. So for us, even the components that you see around the windows right now follow the same logic as the rest of the system. So even if it's wood, it's pre-cut, it's pre-grooved. There's a logic to it so that it fits in the opening because it's an integral part of our system. We used to have a system actually for windows, and we had to take a step back. Essentially, we could clip the windows directly onto the structure. And that was great. It had its challenges in terms of flexibility of being able to choose and work with different window companies in different areas where we were operating. So we switched to a system that would provide that rough opening with the same level of precision as the rest of the structure, where everything is nice, straight, and plumb. Where whether it's an aluminum window or a fiberglass window or a wood window, it's going to be able to be installed easily with that level of precision. In terms of even, let's say, aluminum windows, when you're working with big openings, and this is something that is, I'd say, almost a very common design for bone structure homes, you'll see the size of the windows. What you want to watch out is the hardware, the quality of the hardware that you're using, especially if you have operable windows. It's not a small window, so you need something that's going to be nice, sturdy, and that's going to work well in 2 years, 5 years, 10 years, and way down, right? So when you get to these heavier windows, that's where aluminum can be a good option. That being said, not all aluminum windows are created equal. Right. Same as wood, same as fiberglass. Another key component is, we mentioned, is having everything thermally broken. And this is true for windows, and it's also true for the rest of the shell. A thermal bridge is essentially a highway for the heat to go through or the cold to go through. And this could be metal, where it's very conductive with that heat to go through. So what you want to do is separate that so that you can't have the heat go through just easily. Because even if you have a very good window at the center, and you can have a triple pane window and it's very efficient at the midpoint of the window, that's not where the issue is. The heat or the cold will try to go through the frame, and that's a super
the fastest way possible. Yeah, and when Brendan and I first spoke about this project, we were discussing the strategy for the installation of the windows in the steel structure. And we talked about, originally I believe we talked about having a window with no fin,
Right.
and installing them almost like a commercial application would be. So they could be moved anywhere in that opening and attached with screws, and then using backer rod and sealant to seal the opening. And we eventually settled on this buck system, which enabled us to use our standard nail fin new construction window and apply it like you would on a wood structure, even because of the wood that's behind it and backing it, and then flash it accordingly like that.
The windows in this house went in, what, 2 days, Howard?
Yeah,
Yeah.
2.5 maybe.
It took 2 or 3 months of very patient phone calls between Amy and I and Blaine. to get them all right, get all the measurements done. I was talking to Sherry earlier that when the idea was that once the steel is ordered, you actually order the windows at the same time because the steel is not changing, so the windows better not change. And the idea is that they both take about the same amount of time in terms of fabrication for this mass customization technology that we're now sitting in. And there was not one single window that was out of sort of measurement. That's the nice part about a well-coordinated team. But the nice part was that there were some changes that we had to accommodate for other roofs. And the BareBONE system, all of these bucks are actually able to, and you can sort of see that over here, you can actually move them up at what, Alex, 2-inch increments?
Oh, yeah. 1 or 2 inch increments depending on where they are.
Yeah, and there were, so there were, it's definitely possible, even after the windows get ordered or after other things that you see, to move things around that don't really involve the columns or the beams. So there's, even though there's a lot of things that are really arrive on the truck and there's not really a whole lot of change that you can do easily, the bucks and the window bucks up and down are a very easy to accommodate piece. We could move that window up and down today in very short order. Not so much side to side, but up and down.
Correct me if I'm wrong, but in a standard application, when you do high-end, because you guys do a lot of nice high-end homes with Andersen windows, typically the process, I guess, when it's a stick build, you don't necessarily have the level of precision in the opening. So what we hear from contractors is that typically windows, you'll go and measure the as-built opening for these larger pieces so that you make sure that it's done right. Is that?
That's correct. Well, back to even what Brendan was saying, if your supplier and your manufacturer isn't asking a lot of questions and having a lot of dialogue with you up front, then you're bound for a disappointment when things get delivered. So that's what 70% of my time probably is doing that, putting out fires, finding those red flags before they happen. But yeah, back to your question. What was your question? I lost me, sorry.
No, so I guess where I was going is the level of precision.
Oh, the precision of the openings, okay.
In the openings, we say, often we pride ourselves in saying that because of the precision of the steel and because of the precision of the system,
yep,
we can order windows at the same time as we started producing the steel components, just because everything was drawn in 3D to that level of detail, and we know that what's going to be built on site is exactly what was designed, just because it's like in the Rector set where things get put together.
And you're exactly right.
And that's providing the opportunity.
A lot of times we'll do a site measure, once things are framed, but what that does is it doesn't allow sometimes enough time, it's too far down in the process, where with this, in talking to the installers the other day when I was here, they said, everything fit right in. It was a no-brainer. Everything worked perfectly. So
and Andersen and BareBONE. I don't know how many Andersen windows you've put in, or maybe this is the first one. Andersen is it the largest or second largest window manufacturer?
Yeah, we're the largest.
It's out of Minnesota.
We're based out of Minnesota. Been around for 113 years.
Don't look that old.
Yeah. And we have, manufacturing plants in Minnesota, Wisconsin. We have Canada. We just broke ground on a new one in Arizona that'll be producing our Fibrex product and that product line. So we're moving west, which is a good thing for us out here.
So these windows are wood windows. They're clad in aluminum on the outside, not just for the wildfire piece, but for also the maintenance. The owner in the back has no interest in painting this house or scraping windows or replacing anything else like that. He's a low maintenance guy, which I keep reminding them the difference between low maintenance and no maintenance. But it is kind of a joking thing, because Howard and Merritt have been tending to this parcel for decades, and he would rather play the fiddle and make some pretty cool steel things and just enjoy time with his grandkids. So one of the reasons that we used these aluminum-clad, beautiful powder-coated windows is that they're thermally broken, and we wanted on the design side a wooden feel not more metal in the house. Even though this house is a lot of steel in here, when you walk in, the concrete floors, it's supposed to be kind of a very rustic country setting, and the wood windows for us on this project were right in line with how Andersen.
Well, and remember using the different materials like wood or some of the composites that we use, that is the thermal break in those. So it's not a solid, solid material all the way through. So that slows down that process of heat transfer.
So Alec,
There's one other bit about these windows that's interesting relative to the WUI requirements. WUI requires that you have tempered glass, but they allow composite plastic surrounds around the windows.
yeah, explain that.
So you get a fire, and the first thing that happens is the glass falls out, because of the plastic surround. And it was a give up by the supervisors because of cost. But we didn't want to have that.
It's an interesting, the whole WUI thing is interesting. I was working with CAL FIRE when they were writing that code a little bit, and so there's three things that are required. One of three things. You can have glass block, which isn't so popular anymore, as we know. You might have it in your shower. A 1 hour fire rated assembly, which is the whole window itself, which you're not going to get out of any composite or wood or vinyl or whatever. Or at least one pane of tempered glass. And it's sort of, I know we talked about the fire codes a little bit before, but it's like in Florida, when you see a wildfire, it moves very rapidly, right? So the idea is to keep the envelope intact without being breached. And the fire will have some minimal damage to your home, but move past. That's the idea. But once it breaches the envelope, like a hurricane, once the wind hits the window and the roof pops off, right? So it's the same thing. The whole house will be a loss once it breaches that envelope. So, and you were talking about going up into the eaves and things like that. So it's all part of the puzzle of defensible space and, slowing, keeping that envelope intact. It's very important.
Alex, you've put in more windows, or watched more windows being installed in BareBONE products. Do you have a preference when you see windows sort of going? Can you explain the sort of the innie and the outie, some of the issues that you faced or seen?
So architects, depending on where they are, geographically seem to disagree on what the best method is. It seems like there's a lot of gray areas.
Unbelievable. I've never heard of that.
The way we've designed, like I said before, is an innie window system, and that's partly because we use spray foam as our sole weather membrane. So that's going to be your drainage plane for water as opposed to, say, a building house wrap. The way we use spray foam that backs up straight to the window bucking, the plywood wrap, means that you're not overlapping any sort of flashing system. You're not integrating your window with your waterproofing. Instead, you are basically relying on a sealant and backer rod system. That combined with the fact that your window is actually inset, it's taking less bulk water from the exterior environment. So just naturally having your pane of glass set back is going to protect it from bulk water from the sky. So here, for example, where you've got a nail fin, you have your window further out, you're going to want to take a little bit more action to kind of mitigate the water draining and keeping it away from the actual border of the opening. So it just means an extra layer of peel and stick membrane, and again, flashing that water so that you're bringing it away, not letting it creep towards your window at all.
And that, what you're describing there, that any window or setback to give you that, depth, can also be done with this system and just make that buck a little narrower, and they could be installed farther into that opening because you have a deep wall system, and it would accommodate that just fine.
And I think these windows themselves have a removable nail fin, and so a lot of the windows that come with nail fins, you can choose to take the exact same window, take off the nail fin, and put the window where you want it. So there's certainly no limitations by having that sort of system. Definitely gives you more flexibility either way.
So when we were going through all the designs in the Title 24, there's a U rating for every single window and every single door that's sold. I think Amy would nod her head when I say this. The weakest point is not the windows. even though that's a challenge in any new building today. It's actually these big bifold doors. They're actually hung from the beams above, so that things don't move around, and you can not have to be a big 200-pound full linebacker to move a window back and forth. The idea is that it slides open easily, but all of that ease at the sill of the door. In a hotel, it's not a big deal because you're back up in your hotel room and you're not hearing it. But what we didn't want was a major windstorm in the middle of December or January and this whistling sound through here. So Amy talked me out of some pretty slick little threshold options, because I did not want the phone call from Howard and Merritt on Christmas Eve like, we're hearing the wind through our house, and I don't think that should be happening. Actually, you would even be more polite than that. But one of the issues, and just to move the topic to the doors, is that there's a big trade-off for a lot of these big openings, and Andersen has another product, more expensive, with
It's our Weiland lift slide product.
Right.
Yeah, we have several different big door options. The Weiland lift slide, our multi-glide door, and then bifolding doors as well.
Yeah.
So there's different applications, different options.
We ended up not going with an Andersen bifold, just because the owners really wanted a big opening and not even to see the glass or the screen. They just wanted it open, just like you're seeing today. Does Andersen now make a bifold?
We do make a bifold, yeah. A couple different dimensions in the more classic French style panel, which would have a big kick at the bottom and a little wider style and rail. And then we make a real narrow, more contemporary one as well.
So anyway, that's the. Are there other questions related to the thermal envelope? I addressed it earlier. I think you're aware that the whole building actually has an exterior insulation. You can see the yellow pieces, but the roof will also have an exterior insulation component when the roofing actually starts. I think on Monday. Is that in May?
Sure.
But there's actually another 1.5-inch layer of insulation that goes over the top of the roof before the steel and some of the fiberglass goes down.
I guess same logic as for the windows, not having any thermal bridging.
Right.
There's, I guess, steel buildings from the 70s. There was kind of a big boom in the 70s at some point of having steel homes where you would replace the wood stud with a metal stud, right? So I'm often asked, is it, how are you different from these? Because they had issues with condensation and thermal bridging, and that's where the bad reputation of these buildings came about. So it's completely different. So right now, what we do these days is what we call not insulation, but outsolation. Yep, outsolation, where there's no steel. You don't want to have any steel, and even wood, right, in contact with the outside. So you want to have your insulation covering the entire home. That way there's really zero thermal bridging. It's very hard for the heat or cold to transfer from one side to the other. And that's not just for the comfort inside the home. It's also, you don't want to have these dew points or condensation points in your wall that will essentially result in degradation of your wall system. So as you'll notice, if you see any steel in the house and it looks like it's connecting from inside out, it's actually thermally broken, and there's a fiberglass component that separates the steel from the inside and the outside, so there's no direct channel going from one to the other, and that's what makes, at the end of the day, a really good shell.
One of the few challenges for me and the BONE team was that we wanted these cantilevered systems, and that the steel beams that you're seeing above you actually extend 7.5 feet to the outside. On a 30-degree or 25-degree night in December, that piece of steel is going to be cold, and this piece of steel in here is going to be at 68 or 70 degrees. Where they cross, and if it's cold, just like a cold glass of beer on a warm day, the air, the warm air inside the house will condense against that steel, and water will form and start dripping down the beam. And so we've created a thermal bridge by, and if after we're done here in a couple minutes, you can actually go outside, and we sprayed the first 18 inches or the first 2 feet of the steel beam on this side, so that by the time that thermal bridging has happened, even though it's the same piece of steel, there's a time for that critical piece to get to the temperature, so the inside temperature of that steel will never be at the condensing temperature. Does that make sense to everybody? So there are some aspects that BareBONE would have preferred to have seen, around the thermal envelope, but because this is Sonoma County and there's a lot of overhangs that we're allowed to use, there are things that we had to kind of make up on the fly, and it was really just a couple of phone calls between insulation experts and Alex in particular, who has seen many weird things that are not part of any website. And it's like, well, if you do this, you could call that guy, and let's get back on the phone. And this is definitely not a steel building it's definitely not a wood building where just all the steel has been replaced by steel. It's a much, much more sophisticated envelope theory. So anyway, with that, I want to open it to sort of any questions that we may have raised. Any questions at all? Good, we've answered everyone's burning questions about thermal envelope. I want to thank Alan. Oh, sorry. Please.
Any downside to operable windows as far as their energy efficiency?
Yes. Blaine?
Well, every window is tested as it's operating. So if it's a fixed window, it'll be tested as a fixed window depending on the glass makeup and the frame. So it's tested as a full unit. So each of these, I believe these are 28 or 30 is the U value on those, and I believe it's the same on the large one. So in this, for instance, they're going to be the same. So, and then you have air leakage as well. So you want to make sure that they're gasketed properly, but they're thoroughly tested, third-party tested by laboratories that certify all those outputs. Yeah.
There are many fixed windows in this building because the strategy was to spend dollars and time on areas where we could really guarantee cross ventilation, and when we wanted it closed, at the end of the day, many of the windows in your house that can be opened really never ever get opened.
They don't.
And there are some critical windows in bedrooms from a code standpoint that need to open because of fire exits in the event of fire and egress requirements. So all those have operable windows here. And some of these transom windows will open on days like this, but almost all of the houses, almost all the windows in this house on purpose are fixed. And it definitely was able to save some.
And we see a lot more of that these days. Because you're absolutely right. Most people, if they have a double French door, they never open the other panel. They use that primary panel only, and that's their man door. But fixing the window is going to save some cost. And like Brendan was saying, most people don't open the majority of their windows in their house. They have 3 or 4 that they're go-to windows that they open for ventilation.
Yeah. So with that, I want to thank Alex and Blaine and Charles, and we're around for answering questions. And please walk around this beautiful building. And the best part about this BareBONE event is to actually see the thermal envelope before it gets covered by sheetrock and cladding and all the other fun stuff. The house. So thank you.